Hello everyone, this is Sir Harold, your junior high school mathematics teacher. And in this video, I'll be discussing about equations that are transformable to quadratic equations. And this is under week 3, lesson 1 of mathematics for grade 9. The objectives are the following. So, learners or students are expected to, or at the end of this lesson, students are expected to find the least common multiple of the denominator, or what we call the LCD, from the given rational algebraic expression or expressions. And then, students are also expected to solve equations that are transformable to quadratic equations. In studying quadratic equations, we encounter expressions which are not written in standard form ax squared plus bx plus equals 0. So we need to do some manipulations in order to rewrite or transform these equations to standard form. This includes rational algebraic equations. The principles of least common multiples and operations on algebraic expressions are necessary to solve such equations that are transformable to quadratic equations. By the way, the so-called standard form is this one, ax squared plus bx plus c equals 0. So please take note of that. Now we go directly to some illustrative examples, and let us consider the first item, number 1. Now, we are going to express the given equation quantity 2x plus 1 equals x times quantity x plus 2 to ax squared plus bx plus c equals 0 form, or the standard form. Then afterwards, upon getting this form, we are going to solve it or find its roots or solutions. So for our solution, to be able to transform the given equation like this and solve this afterwards, we must follow the following steps. And these are: simplify the right side by performing the indicated operation, of course. Then group like terms and rewrite the equation in standard form. And this is the actual steps to be carried out. So considering the given equation, so we just copy this one, and this is the equation, 2x plus 1 equals x times the quantity x plus 2. Now, as what the instruction said, we simplify the right side. So we need to carry out the operations indicated in this expression. So particularly, x is to be multiplied to the expression inside the open and closed parentheses. So basically, we're going to apply the distributive property by distributing x to each of these two terms inside the parentheses. So what will happen next is that we copy the left side, and on the right side, x is now being distributed. So x times x is 1 plus x times 2, or 2 times x. And then simplifying the right side and copy the left side, so that is 2x plus 1 equals x squared, which is the product of these two, plus 2 times x, which is 2x. Now, at this point, we have this equation. You will notice that 2x is common to both sides. So if we're going to simplify this equation, the 2x on both sides will disappear. How? Maybe we just cancel them out, or simply we just apply the addition property of equality by simply adding both sides by negative 2, or simply subtract both sides by uh, simply subtract both sides by 2x, or add both sides by negative 2x. But in this case, I simply cancel them out. And what will remain from the equation is this. 1 equals x squared. And from this equation, let us rewrite this to standard form. And the equation becomes 0 equals x squared minus 1. So basically, 1 on the left side is transposed to the right. And this is the resulting equation at this point. And we apply the symmetric property of equality by interchanging the position of the left and the right side of this equation. We have x squared minus 1 equals 0, which is now the standard form of this original equation. So basically, these two equations are the same. And from this resulting quadratic equation, we can now solve this or find its roots by using any of the four convenient methods. Particularly if we're going to use the factoring, okay, we can use it. So again, from this resulting equation, which is now written in standard form, we solve this by factoring. So the left side expression is factorable, and with having a product of x squared minus 1, its factored form is simply x plus 1 times quantity x minus 1 equals 0. And then we apply the zero product property by equating each factor to 0. We will have two resulting linear equations in one unknown. Okay. So for the first factor equated to 0, we have the first equation. And for the second factor equated to 0 also, we have the second linear equation. And from each of these two, we can now solve for x. So for the first equation, this one, x is equal to negative 1, while in the second equation, x minus 1 equals 0, the value of x here is 1. Therefore, what are the roots of this equation? The roots are negative 1, denoted by small letter r, and or positive 1, which is denoted by small letter s. And these are the solutions or roots. Next, number 2, about this one. Transform this equation to standard form x squared. Actually, this is ax squared. Okay, allow me to correct this. Okay, so this is ax squared. Okay. Again, let us repeat for number 2, example number 2. Let us try to transform this given equation to standard form ax squared plus bx plus c equals 0. Then afterwards, for the resulting quadratic equation, we will solve it or find its solutions. So you will notice that this time, the second given equation is actually a rational equation having denominator, which is particularly x minus 2. Now, for us to rewrite this given equation to standard form, we must eliminate the denominator. Now, how do we eliminate the denominator? By simply identifying the LCD or the least common denominator. Since we are looking at only one type of denominator, which is x minus 2, understood the LCD is that quantity itself, which is x minus 2. Okay. So for our solution, okay, wait. So again, for our solution, as what I've said a while ago, we must clear the given equation from the denominator. Since we only have one type of denominator, which is x minus 2, therefore understood that the LCD is that expression also, which is x minus 2. Now, and then what shall we do with the LCD? This is the one we're going to use to eliminate the denominator x minus 2 by how? By simply multiplying both sides by the LCD x minus 2, meaning each term on both sides must be multiplied by the LCD x minus 2. So if we're going to enclose this equation in a pair of brackets, meaning we're going to multiply each term by that LCD. And what will happen to the equation? Okay, will be like this. Each term are now being multiplied by x minus 2. And if that will happen, we can cancel the denominator. And what will remain from the equation is this: x squared plus 3 times this quantity inside the parentheses equals 2. So by rewriting the equation without those x minus 2, because they are now cancelled out, the equation becomes x squared plus 3 times quantity x minus 2 equals 2x, which is at this point the equation is now cleared from any denominator. Then the next step is we simplify this one, the expression having an opening and close parenthesis, by applying the distributive property, meaning 3 is to be distributed to each term inside this open and close parenthesis. As a result, the left side now becomes x squared plus 3 times x is 1 minus 3 times 2 is this one, then equals 2x. Then simplifying the left side further, we have now x squared plus 3x minus 6 equals 2x. And 2x to the right must be transposed to the left. And it should be combined with 3x, because 2x and 3x are the similar terms. Okay, so we inserted negative 2x between 3x and negative 6. And the left side has now 4 terms. And since there is nothing left on the right side, we will write the right side as 0. And 3x minus 2x can be combined since they are similar terms. So the resulting quadratic equation becomes x squared plus x minus 6 equals 0, which is now written in standard form. And from that resulting equation, we can now find its roots by factoring, since this expression on the left side of the equal sign is factorable. And what is its factored form? It's actually quantity x plus 3 times quantity x minus 2 equals 0. And then applying the zero product property, we equate each factor to 0 in order to obtain two resulting linear equations. And these are the equations: x plus 3 equals 0, or x minus 2 equals 0. And we can now easily solve each of these two equations. And the solutions are, for the first equation, we have x is equal to negative 3. And for the second equation, x is equal to 2. Therefore, the solution or roots to this given equation, which is this one, the original rational equation, are negative 3 and or positive 2. Next, for number 3, we have another rational equation to be written in quadratic equation standard form. And we are also asked to find its solution or solutions. But this time, we are dealing with not just one, but three different denominators. And these are x minus 4, x plus 4, and x squared minus 16. Now, just like in the previous example, in order for us to transform this equation to standard form, we must clear the equation from any denominator or denominators. So we need to identify what would be the LCD of these three denominators, or the least common multiple of these denominators. So basically, you just recall what you have learned about the least common multiple. So in this case, the LCD is x minus 4 quantity x plus 4. So basically, we just look at the first two denominators, we get their product, and that is the LCD. Now, how come that we did not consider x squared minus 16? Actually, we just did. Okay, if we try to investigate this expression x squared minus 16, this is actually a special product which has a special factored form. And what is the factored form? X squared minus 16, when you factored when you get its factored form, it is actually the same as the LCD, which is quantity x minus 4 times quantity x plus 4. Meaning that this x squared minus 16 is the LCD itself. We only consider the factored form. Okay? And just like in number 2, what shall we do with the LCD? We multiply this to each term of this rational equation on both sides. Okay, so rewriting the given equation, and each term is to be multiplied by the LCD. Yun. Both sides. So because of this, the equation now becomes longer, no? Because each term is now being multiplied by the LCD, quantity x minus 4 times quantity x plus 4. And because of this, at this point, we can now remove the denominators by cancellation, like this. Okay? You will notice that x squared minus 16 is the same as quantity x minus 4 times quantity x plus 4. So if we're going to cancel this expression, okay, this denominator is also the same as this factored form. And of course, if we're going to rewrite the equation eliminating those expressions that are already cancelled, it goes like this. X plus 4 plus x minus 4 equals x squared, which is now cleared from any denominator. And on the left side, we simply combine similar terms. We know that x plus x is 2x, and if we combine 4 by negative 4, or we subtract 4 by itself, it will result to 0. So at this point, the equation will now become 2x equals x squared. And from this equation, we can easily rewrite this to quadratic equation in standard form. Or at first, 2x transposed to the right. So the left side becomes 0, but when it comes to the right side, we have now the expression x squared minus 2x. And we apply the symmetric property of equality by interchanging the position of the right and the left side. The equation is now x squared minus 2x equals 0. And from this resulting quadratic equation, we can now find its roots by, again, factoring. Although we could use other method to find the roots of this equation. We could also use completing the square and quadratic formula, which is the more reliable method if we compare the method of factoring. But in this case, we use factoring because the left side expression can be easily factored. So, again, factoring the left side, it is also the same as x times the quantity x minus 2, then equate to 0. And then, again, applying the zero product property, we equate each factor to 0 in order to come up with two resulting linear equations in one unknown. For the first equation, x equated to 0, so automatically we get the first root, which is 0. And for the second equation, we have x minus 2 equated to 0. And from the second equation, the value of x is 2. Therefore, the roots are what? 0 and positive 2, which are taken from these two values of x. Okay? Now, to sum up what we have just learned from these three previous examples, these are the following suggested steps for you to follow in order to solve equations that are transformable to quadratic equations. And these are what? First is find the least common denominator of the given fraction or rational algebraic equations. Second, multiply each fraction by the LCD to eliminate the denominators. Then third, simplify if possible. Then write the resulting equation in standard form ax squared plus bx plus c equals 0. Fifth, use any of the four methods of solving quadratic equations. So if we, just for a recall, I have discussed four methods of solving this type of equation, and these are what? Extracting the square root or square roots, factoring, completing the square, and quadratic formula. Now, upon solving the quadratic equation by any of the four methods, we look back or check the solution if there is a presence of what we call extraneous solution or extraneous root. Now, what does this mean? Ano ba yung tinatawag na extraneous root? Okay, I'll explain about the extraneous root. So we now go to the next slide. Extraneous root or extraneous solution, what is this? So when we talk about extraneous root, we consider a rational expression or fractional algebraic expression. The solution is considered extraneous if it will make the denominator of the expression equal to 0. Now, take for example that any fraction whose denominator is 0, meaning that the fraction becomes meaningless or not defined. Okay? Take for example number 1, we have an expression 2 over the quantity x plus 3. Now, any value can replace x, but not negative 3. Meaning to say, we can accept any value of x but not negative 3, because negative 3 will make the denominator x plus 3 0. Okay? So, meaning to say, the value negative 3 is the extraneous solution or extraneous root. Okay? Now, for you to fully understand what extraneous root is, let us consider another example. Suppose we have another fraction, which is 5 over the denominator for x plus 3. Now, what do you think will be the value of x, which will make this fraction meaningless? Now, to answer the question, what we're going to do here is we consider the denominator for x plus 3 and equate that to 0. And from this point, we solve this resulting linear equation in one unknown. So if we're going to solve that, you will notice that from this step-by-step way of finding x, we obtain negative 3/4. Therefore, the value of x who is responsible to make this expression 0 is negative 3/4. And negative 3/4 is what we call the extraneous root. Okay? Ayan. So if we're going to read this, in other words, if x is equal to negative 3/4, the expression 5 over the quantity for x plus 3 becomes meaningless because the denominator becomes 0 here because of this value. Therefore, this value is an extraneous root. Okay? And with that, my discussion about this topic is done. And thank you. And we will see you next time for another topic in mathematics.